Hello everyone. In this video, we talk about Bernoulli distribution. Consider the following experiments. Suppose we flip a coin once. We define the random variable x by assigning a value 1 for x if the flip turned up head. Otherwise, assign a value of 0 for x. Consider another experiment. Roll a die once. Define the random variable, say y. If the number showed up is an odd number, we assign a value 1 for y. Otherwise, assign a value of 0 for y. Consider another experiment. We pick one student in the class. We want to know whether the student passed the exam or not, so we define the random variable w. If the student passed the exam, we assign a value of 1 for w. If the student does not pass the final exam, then we assign a value of 0 for w. What are some characteristics in common regarding these three experiments? We only perform the experiments once. And for each experiment, there are only two outcomes. An experiment performed once that can result in one of two possible outcomes is called a Bernoulli experiment or a Bernoulli trial. The two possible outcomes are classified as a success and a failure. We use S to denote successes and F denote failures. The outcome we are interested in is denoted as success, and we assign a value 1 to the random variable. If the outcome is a failure, we assign a value 0 to the random variable. A random variable whose only possible values are 0 and 1 is called a Bernoulli random variable. Let's consider the experiments at the very beginning of the video again. Flip a coin once. If we are interested in flipping a head, then we will define the event head as success. And we will define the random variable x by taking x equals 1 if the flip is a head. If the flip is a tail, then we assign a value 0 for x. If we are interested in flipping a tail, then we will define the event tail as success. And then we will define the random variable by taking x equals 1 if the flip is a tail. And if the flip is a head, we assign a value of 0 for x. How about the experiment in picking one student in the class? If we are interested in whether the student passed the exam, we will define the event pass as success. Define the random variable w. If the student passed the exam, we assign a value 1 for the random variable. Otherwise, we assign a value 0. If we are interested in whether the student failed the exam, we will define the event fail as success. We define the random variable w. W equals 1 if the student failed the exam. Otherwise, assign a value 0 for the random variable w. Let x be the random variable and denote the probability of success by p. Then the probability mass function of x is given in the following table. X has a value 1 with p of x equals p, the probability of success, and x equals 0 with probability 1 minus p. In this table, the PMF of x, p is the parameter of the distribution. And this is the Bernoulli distributions and we use the notation X follows a Bernoulli distribution with parameter P. Let's compute the mean and the variance of a Bernoulli distribution with parameter P. Recall the formula to compute the mean, the expected value of X. This equals to the summation of X times P of X. And here, the possible values of X is 1 and 0 only. So we get 1 times P plus 0 times 1 minus P. Upon simplification, we get P. The expected value of a Bernoulli distribution with parameter P equals P, the probability of success. And how about the variance? We need to compute the expected value of X squared. For Bernoulli distribution, we have 1 square times the probability P plus 0 square times the associated probability 1 minus P. Upon simplification, we get the expected value of X squared equals P. This is the expectation of X squared. We need to get the variance. Using the shortcut formula, the variance of X equals the expected value of X squared minus the square of the expected value of X. So we have P minus P squared equals P times 1 minus P. And this is the expression for the variance of a Bernoulli distribution with parameter P. This is everything for the Bernoulli distribution. Thank you for watching. In the next video, we will move on to the binomial distribution. And I will first define what is a binomial experiment.